In this video, we are going to look at the rule of addition of probability. Let's say we carry out a trial where we flip a coin. Upon flipping a coin, there are only two possibilities that we get. We either get head or we either get tail. Head and tail are such events that don't occur at once. That is, if you flip a coin, you either get head or you get tail. It is not possible to get both head and tail at the same time. And such events are what we call mutually exclusive event. We call them mutually exclusive events. Again, mutually exclusive events are such events that don't occur at the same time. Let me show you with the help of a Venn diagram. Let's say this right here is the Venn diagram of the trial that we just carried out. This right here is all the heads that we get, and this right here is all the tails that we get upon carrying out the trial. And as you can see in the Venn diagram, the two sets, that is the set of heads and the set of tails, they don't overlap with one another. That is, there is never a situation when head and tail occur at the same time. In this particular condition, if you have to find the probability of getting head or tail, you simply add the two probabilities, probability of getting head plus probability of getting tail. The reason being, in this case, the probability of getting head and tail, that is getting head and tail, is 0. So, mutually exclusive events, they are such events that never occur at the same time. And since they never occur at the same time, the probability of getting those two events at the same time is obviously 0. And the probability of the occurrence of two events can be calculated by simply adding the probability of each event. Let me give you another example. Let's say I have a dice right here. Okay, let me draw a better dice. Okay, so I have a dice right. Shit, it's a messed up dice. Okay, I have a dice right here. So I carry out a trial. The trial is rolling a dice. Once I roll the dice, there are 6 different possibilities. I either get 1 or 2 or 3 or 4 or 5 or 6. There is never such an event, or there is never such an occurrence where 1 and 2 occur at the same time. 1 and 2 and 3 occur at the same time. When you roll a dice, you get only one outcome, that is either 1 or 2 or 3 or 4 or 5 or 6. The rest of the numbers, they do not occur. And these events are what we call mutually exclusive events. So in this case, the probability of getting 1 or 2 is simply equals to probability of getting 1 plus probability of getting 2. Because the probability of getting 1 and 2 at the same time is 0. Again, the probability of getting 3 or 4 or 5 is equals to probability of getting 3 plus probability of getting 4 plus probability of getting 5. Because you are never gonna get 3 and 4 and 5 at the same time. Let me make the concept clearer with the help of an even better example. Let's say I have a bucket right here, and this bucket contains 4 red triangles, 4 red squares, 3 blue triangles, and 5 blue squares. So the first question is, what is the probability of getting a red triangle? The probability of getting a red triangle. So for that, you have your simple formula, that is desired outcome divided by all possible outcome. So what is the total number of possible outcomes in this particular example? 4 this right here, this right here, this right here, and this right here. Add all of them together. 4 plus 4 plus 3 plus 5. So these are all possible, all possible outcomes. What you need are your desired outcomes. What are your desired outcomes? Your desired outcome is to get a triangle, a red triangle, not just any triangle, a red triangle. And there are altogether 4 red triangles. So that's your desired outcome. Desired outcome. So the probability comes out to be 4 divided by 16. Second question. What is the probability of getting a triangle? Simply a triangle. So there are a total of 16 total possibilities, out of which you have a total of 4 plus 3, 7 triangles. So the probability is 7 by 16. Third question. What is the probability of getting red? So a total of 16 possibilities or 16 possible outcomes, and desired outcome is getting red. And there are a total of 4 plus 4, 8 red. So the answer is 8 by 16. Now here's your tricky question. That is, what is the probability of getting, a red or a square? Let me show you with the help of a Venn diagram. So this is the Venn diagram. See, you have the possibilities of getting red. Wait. You have your possibilities of getting red. So that's your red. And there are altogether 4 plus 4, 8 possibilities of getting red. Then you also have your possibilities of getting a square. Possibilities of getting square. There are altogether 5 plus 4, 9 squares that you can get. 9 squares. But the thing is, when you pick stuff at random from this bucket right here, you have a possibility of getting red because there are red stuff, square because there are square stuff, and also there's your square as well as red stuff, which is the common between the two. There are altogether 4 squares that are also red. So in this trial, you can have events such as getting red, getting square, or even getting a red square. That is two different events occurring at the same time. And this is what we call not mutually exclusive events. In mutually exclusive events, you had events that never occurred at the same time. Here, since you have two different events occurring at the same time, they are not mutually exclusive. Okay, so that's one concept. But the thing is, you need to find the probability of getting either a red stuff or a square stuff from this bucket when you pick something out of it. So that is going to be equal to probability of getting red stuff, right? Probability of getting red plus probability of getting square. But now here's the thing. There is also a probability that you might get a red square. And this red square is a part of red as well as a part of square. I mean, this red square is added in red as well as added in square. So to get the correct probability, you have to remove this part from the equation at least once. So you have to remove the probability of getting red and a square. Again, so what is the probability of getting red or a square? So the probability of getting red is 8 out of total, which is 16. The probability of getting square is 9 out of total, which is 16. But then there's also the probability of getting red square, which has been added twice in red as well in square as well. So you need to remove it once. So probability of getting red square 4 by 16. Again, what is this? This is the probability of getting red. This is the probability of getting square. And this is the probability of getting red and a square. In mutually exclusive events, that is events where two can't occur together, the probability of getting red and a square would be 0. So the probability of getting red or a square would simply be equals to probability of getting red plus probability of getting a square. Okay, last example. Let me give you last example. Let's say what I have here is a deck of cards which has a total of 52 cards. Now the question is, what is the probability of getting a king or heart? So if I close my eyes and pick a card, there is a probability of getting other cards. There is a probability of getting king. There is a probability of getting heart. But then there is also a probability of getting king of heart. That means two events occurring together. So this is also not mutually exclusive. It's not mutually exclusive. And you know the formula for not mutually exclusive. So the probability of getting king or heart is equals to probability of getting king plus probability of getting heart minus the probability of getting king and heart. Again, let me show you with the help of a Venn diagram. Let's got all of this. So let me show you the same question in a Venn diagram. So here's the Venn diagram for the question. So there is a probability that you might get a king. There is a probability that you might get a heart. There are altogether 4 kings and altogether 13 hearts in a deck of 52 cards. However, there is also a probability that you might get king of hearts. There's 1 king of heart in a deck of cards. So the probability of getting a king or a heart is going to be equals to, what's the probability of getting king? 4 by 52. Plus, what's the probability of getting heart? 13 by 52. But then also there's also the probability of getting both king and heart at the same time, which is added here as well, which is a part of that as well and this as well. So you need to remove it once. So 1 by 52, which is equals to probability of getting king plus probability of getting heart minus probability of getting king as well as heart. And if it was mutually exclusive, let's say if it was mutually exclusive, this part would be equals to 0. So that's it for rule of addition of probability. Here's the revision. Rule of addition. Okay, here's the revision. You have rule of addition of probability. Under this topic, there are 2 possible situations. One situation is where the events are mutually exclusive. Mutually exclusive. That is, the 2 events, they don't occur at the same time. If this is event A and this is event B, event A and event B, they don't overlap with one another. And there is not mutually exclusive events where you have events that can occur at the same time. So let's say this is event A and this is event B. There is a possibility that event A and B can occur at the same time. The probability of getting event A or event B in case of mutually exclusive events is equals to probability of getting A plus probability of getting B. The probability of getting A or B in case of not mutually exclusive is the probability of getting A plus probability of getting B minus the probability of getting both A and B.